All right, so now let's identify the inverses of numbers, okay? So we'll start with number 11, and for all these, we're trying to find both the additive inverse and the multiplicative inverse of each number, all right? So remember, the additive inverse is just the opposite, right? So let me write that in here, opposite. Oops. And the multiplicative inverse is just the reciprocal. Reciprocal. All right. So the additive inverse of 15 is just negative 15, right? And the multiplicative inverse is the reciprocal. So when you have a number that's not a fraction, you can just put a 1 underneath, right? So 15 over 1 is what 15 is as a fraction. So if we flip that over, we get 1 over 15. All right, easy peasy. So number 12, the opposite of 1.25 is negative 1.25, right? So that was pretty easy. The reciprocal, this is a little bit trickier. So, you know, technically we could just put 1 over 1.25, but let's simplify that, right? Because we don't usually want decimals in a fraction. So one thing we could do is, and there's a few different ways we can do that. One thing we can do is we can just move the decimal here 2 spots to the right, and we could do the same thing here, that invisible decimal on the right. So what we could get is 100 over 125, and then we can reduce that. I think 25 is the greatest common factor, so we divide by 25 and we get that, right? Now, the other way we can do it is we can convert 1.25 to a fraction, or a mixed number, 1 and 1/4, right? 0.25 is 1/4. Then we can convert that to an improper fraction by multiplying 1 times 4 and then adding that to the 1 on top, so we get 5 over 4. And then that's pretty easy to flip around. If you flip that around, then you get to 4/5, right? So 4/5 is the value for the multiplicative inverse of 1.25, okay? All right. Or if you want to convert that to a decimal, it would be 0.8, right? 4 over 5 is 0.8. So that's another way you could write the reciprocal. All right, anyway, so I'll take either 0.8 or 4/5 for the correct answer on that one, because those are simplified versions of these other values that we got, okay? All right, so that one was a little tricky. They're not all that bad, though. Number 13, the additive inverse of negative 4/5 is just positive 4/5. Okay, and then the multiplicative inverse is the reciprocal, so that would be negative 5/4. Okay, so when you find the reciprocal, you don't change the sign, you just flip it. All right, number 14, the additive inverse of 3 3/4 is negative 3 3/4. The multiplicative inverse is I have to flip it over, right? So before I can flip it over, I have to convert it to an improper fraction like we did over here, right? So I'm going to multiply 3 by 4, and then I'm going to add whatever I get to the numerator, right? So it'll be 3 times 4 is 12, plus 3 is 15 over 4. So when I flip that over, I get 4 over 15. All right, so those are your values, the additive inverse and the multiplicative inverse there. All right, next we have negative 0.2, additive inverse, super easy, just change the sign, positive 0.2. The multiplicative inverse, we could do 1 over negative 0.2, and you could actually just plug that in your calculator and give it to you. It would give you the answer. I could move the decimal. There's once again a few different ways we can do it. I'm gonna make this one, it's negative 2/10, right? So I'm gonna make it negative 2 over 10, which if I flip that over, it'll be negative 10 over 2, and that equals negative 5. Okay, and so put negative 5 there. By the way, notice how I put the arrow here. It's not an equal sign because I'm flipping it. So just be careful, you know, not to say that this equals this, because they're not equal, right? Inverses don't equal their numbers don't equal their inverses, right? So be careful with that. All right, number 16. This one's a little different because we have a radical here. But the additive inverse is no big deal. We just change the sign. So it's a positive root 10. So all I have to do is make it a negative root 10. It's the opposite, right? Now, the reciprocal would be 1 over root 10. Okay, and we're going to talk about how to simplify that later on when we deal with radicals. But there's a way to rationalize the denominator. And maybe you've seen that before. But we're going to leave it like this for now, okay? So just 1 over root 10.